Today we're going to go over conditionals and data structures part one. I know last time we went a little bit over, so I'm hoping that today this will go a little faster for the PowerPoint so we can have more time for the demo at the end. And I also have the assignment one or assignment two. I did that myself as well, and if we have time, I'll review that at the end. It just won't be part of the recording, just so future classes won't, have the answer and such. So, all right, so let's get started. Today we're going over conditionals and data structures part one. So conditionals. Conditionals are basically how we have any logic for deciding, if a certain case applies, then we want to do something. If that case doesn't apply, then we do another thing. So to do that, we have an if statement or an if else statement. So with an if statement, you have your keyword if to start out, and then you have a Boolean expression. It can be a Boolean value or a Boolean expression. So remember, a Boolean expression is anything using those comparison operators. So if you wanted to, see if two numbers are equal to each other, you can have A equal B, or you could see if A is less than B. Anything like that would work there. You could also just say Boolean one was a Boolean value itself. So it's so that's just true or false. You could have that value there. It depends really what's stored in the variable Boolean one, but it should at least be it should evaluate to a Boolean, so it should be like a Boolean expression or a raw Boolean value. So with this statement, you have the if Boolean one, and then something important to note here is this indentation here. Python requires indentation for analyzing the code, basically. The way you know that the next line of code isn't part of this above if statement is that it's no longer indented. So there's this thing in Python between spaces or tabs. You can choose whichever one you want, just make sure you're consistent. PyCharm will take care of that for you. You can kind of mix spaces and tabs in PyCharm and it'll figure it out. But if you're using a raw editor, like something like Sublime Text or anything like that, you have to make sure that your spaces and tabs are consistent throughout. So you just use spaces or you just use tabs. But anytime you have a Boolean expression, you start out with your keyword if, or conditional, you start out with your keyword if, the Boolean or Boolean expression, and then a colon here. And then you have to indent under there. And then anything indented under there will only happen. So this code will only run in the case that that Boolean is true. So in this case, we know that Boolean one is true. So I have it print out Boolean one is true. We can also, have Boolean expressions, like I said, so we can check about Boolean one or Boolean two. So if either of Boolean one or Boolean two is true, then this code will print. So say that Boolean one is false. If Boolean one is false and we run this code in this first block right here, Boolean one is true will not print out because Boolean one is false, but say Boolean two is true, then this will print out because it's an or statement. So as long as at least one of them is true, then that'll print out. Here, let me close these blinds real fast. All right. So that's a simple if statement. If we instead wanted to have a situation where if something occurs, then we do one thing. If that isn't the case, then we do another thing. Then we can have an if else statement. So with the if else, you have your if first, then your Boolean or Boolean expression. And if that's true, then this code will output. Else or otherwise, then this code will output. Both of them can't output. It has to be one or the other. So if this is true, then we'll print Boolean one is true. If Boolean one is false, then we'll print Boolean one is false. Both will never be printed at the same time. Cool. So conditionals continued. So say you want to chain together a few Boolean expressions. So you want to go, if Boolean one is true, then we want to print out Boolean one is true, but who knows about Boolean two? The reason who knows about Boolean two is because as soon as one of these lines evaluates to true, that code is executed and everything else in your elif else doesn't evaluate at all. So we'll never see Boolean two output here. But if Boolean1 is false, then it'll come to this elif block here and evaluate whether or not Boolean2 is true. If Boolean2 is true, then we'll print Boolean2 is true. And at this point, we know that Boolean1 is false because the only way you could have gotten to this elif block is if Boolean1 was false. So in this case, we do know something about Boolean1. But up here, if Boolean1 is true, we know nothing about Boolean2 yet because we haven't gotten to this line of code there. And if both of them are false, then we'll end up in our else block. And then, we can print out both Boolean1 and Boolean2 are false. And we know that because this evaluated to false up here, this evaluated to false here, and that's the only way we were able to get to our else block down here. And then we can chain together as many elifs as we want. So in this case, I have, if we want to see if Boolean1 and 2 are both true, then we can have our Boolean expression up here and print out Boolean1 and Boolean2 are true in this case. So then we know that both Boolean1 and 2 are true. Up here, we were only recognizing that Boolean1 was true and we had no clue about Boolean2. But here we want to know about Boolean2, so we can check if both are true. Then we'll output, both of them are true here. Elif Boolean1, then we know that Boolean1 is true, but Boolean2 is false because this didn't evaluate to true, but this did. So we know that one of these must have been false because our and statement requires both of them to be true. So if we end up in our elif here, we know that at least one of those must have been false. And if this evaluates to true and we see this statement output, then Boolean1 is true, Boolean2 is false. Same logic goes down here for elif Boolean2. So at this point, we know Boolean1 is false because this didn't evaluate to true up here, but Boolean2 is true because this line of code is outputting. Else, and this is in the case that none of these up here evaluated to true at any point, then we would just print both Boolean1 and Boolean2 are false because that's the only way we end up in this else block down here. There's also ways you can do shorthand conditionals. Just for now, I just want you to know that these exist, but don't actually do these. They're harder to read. They're very useful once you get the hang of programming a little more and you're comfortable with Python. But for now, I really want you to be focusing on the longhand. I just want you to know that these exist in case you ever see them in code out there. So we can have a shorthand basic if, where we just have if, the Boolean, and then colon, and then the value we want to print. So it's basically just like what we saw on the previous slide. Oops, sorry, I went ahead one. It's like we saw up here with just our simple if, except we just moved that up here. So it basically makes it a one-line if statement. We don't really want to do that though, because you can see here, PEP 8, which is the style guide for Python that actually came up in one of the questions for the assignment this week, is telling me that I shouldn't do this. And that's because it doesn't look good, it's hard to read, and it's better to do it the right way and just tab this down under here. We can also do a shorthand if else. This is something that you might see more often than the shorthand if. But again, just focus on the actual, tab together multi-line ifs for now. But you can have, print Boolean1 is true if Boolean1. So this will only output if Boolean1 is true. Else we'll print Boolean1 is false. So just know that these exist. I don't want you to worry too much about these right now. I just want you to know that they're out there. We're not actually really going to use these at this time. So conditionals can also be nested within each other. So anytime we talk about nesting, that's putting something inside of something else. So you can add a conditional within another conditional. Just be mindful of indentation, because again, indentation is extremely important in Python. You need to make sure that, so anything that's indented under this if, basically anything indented after this colon, that's what evaluates only as part of that initial if statement up there. And one thing that PyCharm does to make this pretty helpful for knowing what's in there is you can see these little angle things up here. So this, oops, didn't mean to do that, sorry. So this tells you like there's a whole block of code here. These top two things, anything within these two lines only applies to this if up here, and then same thing goes for down here. There's also these little these gray vertical lines here. So when you have a nested one, so this if Boolean 2 is nested within the if Boolean 1. So this will only evaluate if Boolean 1 is true. So you can see this kind of gray line here, which tells us that anything within this gray line is part of this if statement up here. So all this stuff tabbed in here will only evaluate in the case that this evaluates to true. Then we can further nest there, and you can kind of nest infinitely. You're not necessarily going to want to do that all the time. There's a saying in Python that flat is better than nested. We'll get into the style guide of Python down the line. But yeah, you want to refrain from indenting or nesting as much as you can here, because something we could have done is, just chained these together and had if Boolean 1 and Boolean 2 and Boolean 3, then we print that. But there are cases where you need to nest. So just keep in mind what you need to do, and only nest if you really need to. But yeah, you can nest them like this. So in this case, we have if Boolean 1, if that's true, then we evaluate if Boolean 2. If that's true, then we evaluate if Boolean 3, and if that's true as well. So all three of these are true, then we print Boolean 1, 2, and Boolean 3 are all true, but who knows about Boolean 4? Because Boolean 4 only evaluates in the else block. So if Boolean 1 and Boolean 2 evaluate to true, but Boolean 3 evaluates to false, then we end up in this else block down here. We have Boolean 1 and Boolean 2 are true, but Boolean 3 is false. And who knows about Boolean 4? Again, because we don't look at that until the else block, and this else block is for Boolean 1 up here. Then, and you can tell that because they're tabbed in the same amount. Basically, they have no indentation. So then if Boolean 1 is true, but Boolean 2 is false, we don't even evaluate this here. So we won't know what happens with Boolean 3. We come down to the else block that correlates with this if block up here. So, you just go straight down, same amount of indentation. And then here we would print Boolean 1 is true and Boolean 2 is false. But who knows about Boolean 3 and Boolean 4? We don't know about Boolean 3 because we never got into this block up here where we evaluate Boolean 3. So who knows? So then if Boolean 1 is false, then we come down here to this else block and we evaluate whether or not Boolean 4 is true. If Boolean 4 is true, then we would output that Boolean 1 is false, Boolean 4 is true, but who knows about Boolean 2 and Boolean 3? Because those were never evaluated. They're only evaluated in the case that Boolean 1 is true. Else, so if we end up down here, Boolean 1 is false, we end up in the else block, and then we evaluate if Boolean 4. If Boolean 4 is also false, then we end up in this else block down here. Again, it's indented down there. We would say Boolean 1 and Boolean 4 are false, but who knows about Boolean 2 and 3? Again, because we never evaluated Boolean 2 and 3, because they're in the they're only evaluated in the case that Boolean 1 is true. Cool. So before I get into data structures, any quick questions on conditionals? All right, great. So data structures. A data structure is essentially a means for storing and organizing a collection of data values. It's generally composed of primitive data types. The primitive data types are what we learned about in our last lecture together, which are like strings, booleans, numeric data types, so ints, floats, complex numbers, things like that. So those are all our primitive data types. So generally a data structure is composed of primitive data types, but they can include other data structures nested within them. Again, here's nesting coming back up. Nesting a data structure would be like having data structure A inside data structure B, and we'll see what that might look like in our demos later. So each data structure has their own set of methods, and a method is a defined action that can be performed on the data structure. Methods are called on a data structure using dot notation. So if we have our data structure, oops, I need to stop clicking. So if we have our data structure and we call it data structure here, then we use this dot here. So that dot is very important. This is the dot notation. Then we have our method that we call off of it, and our methods will always have the parentheses after it. If you don't have the parentheses after it, that's called an attribute of the data structure. And we'll learn about attributes down the line, more when we get into actually building our own objects, because you can do this similar thing here of the dot notation on objects, but again, we'll learn about that later. Just know right now that we have the data structure dot the method that you want to call on that data structure. And we'll see examples of this in a minute here. So there are many different kinds of data structures, each with their own relative benefits and uses. Some examples of them in Python are sets, tuples, arrays, and lists. Arrays and lists are essentially the same thing. Dictionaries, objects, and there's even more that go on from there. You can create your own data structures, but the things we're mostly going to focus on in this class are going to be these ones up here. And today we're just going to learn about sets, just to get a straightforward introduction to data structures there. All right, so sets. If you're familiar with math, especially discrete math, sets are huge in discrete mathematics. A set is an unordered collection of unique values that are immutable. So unordered. The elements within a set are not ordered. You can enter them in any order you want when you're creating the set, but the order is not maintained. So here I have 1, 4, 6, 8, 9, 3, 54, 7, and 8. But then when that actually evaluates, because I entered this in the REPL environment, that just outputs in order. In the back end, basically Python is kind of sorting it. But it's actually unordered. There's no way to reference the specific order of this data set. So if you need order, if you need your data to be ordered, the set is not the right data structure for you. But there are many cases where you don't care about the order of the set. Or the order of your data. So the set would be the right data structure in that case when you don't care about the order. So something you'll notice here is I have these curly brackets here. That's how you define a set. That's one of the ways you can define a set. You can do it like this with just curly brackets, or you can use the constructor. And the constructor is just the actual set function with the parentheses after it. And then you can put in data into there. But most commonly, you're going to want to define your set with the curly brackets. So it has to be, so then, all right, back to our definition of a set. The values have to be unique. So all of the elements in a set must be unique. Duplicates are not allowed. So in here, I tried to create a set that has 3 1s, 3 2s, 3 3s, and 3 4s. That evaluates to just 1, 2, 3, 4 because it ignores any duplicates and it just it basically throws them away. So if you need multiple instances of the same data type in your set, the set isn't the right data structure for you. So you would need to use a different data set, and we'll talk, or data structure, and we'll talk more about those later. But important to note, if you try to add something to a set twice, they won't show up in your resulting set. They have to be unique values. And finally, immutable. Once defined, you cannot change the value of the elements in the set, but you can add and remove the elements from the set. So the key thing here is the value of the elements. You can change the elements, but you can't change the value of the elements. So if you put an item into the set, first off, there's no way to reference that item in the set. You can't find this. You can't find a specific item in a set. You can determine if an item is in a set, but you can't find a specific item in a set. There's no way to find like, oh, what's the second item in my set? First off, that doesn't make sense, right? Because sets are unordered. So you can't find the second item in your set when a set is unordered. And then, and then you also can't change that value. So because you can't reference, say, this number 2 in your set, you can't actually change that value, essentially. But what you can do is you can add and remove elements from the set. So you can't change the value of the elements in the set, but you can change the elements of the set. So just want to repeat that because it's very important. You cannot change the value of the elements, but you can change the elements themselves. So we define this set. There's no way for me to change the elements in that set here, but I can add an element to the set. And this is using the add method on my set. So you called it using dot notation, where I'm adding the value 5 to my set. Now, if I output my set, I see that it includes the value 5. I can also remove an element from my set. So again, this is using the method remove with dot notation. I want to remove 3 from my set, and then I output my set. I have 1, 2, 4, and 5. And we'll learn more about these methods in another slide here. So as I mentioned already, you can define them in one of 2 ways. You can define my set using the set constructor, which is basically the set method. This is like in our previous lecture when we saw the string the string function. And sorry, I said set method. I meant set function. If it's, a method is only when you have the dot and then method there. A function is kind of like a standalone. So we use the set function. It's also called a constructor. So you have my set equals set here, and this creates a set. But you could also just have my set equals, and then you just give like an empty set here. So you have your curly brackets and nothing in it. That's an empty set at that point. Yeah. So any questions on the intro to sets before we move on and learn a little bit more about sets?
Yes, please.
Yeah.
You talked about the set not being mutable, that is, it's immutable. But then
Correct.
I see you can add another element in the set. How I thought by saying it's immutable, you were not going to be able to add anything else.
Right. Yeah. Okay. So that part is always a little confusing here. So the values themselves are immutable. So I can't change. So like right now, I'm just storing numbers in this set. So I have 1, 2, 3, 4, 5. Say I wanted to add 5 to all the values in my set. I can't do that because I can't change the values of the set. I can't change the elements once they're in the set, but I can remove the elements themselves. I can't change their value though. So it's the value inside the set that's immutable. It's not the set itself that's immutable. Does that help?
Yeah, it's clear. Thank you.
Awesome. Yeah, and we'll see about that in a few minutes here. But yeah, like there's no way to add 5 to every element in this set. But there is a way to, I could remove all of these items in the set and then add 5 to them. So I could then put the number 6, the number 7, the number 8, and the number 9 back into the set after removing these ones. So that's the only way you can change the values in the set is to remove them and then replace them. So great question. Any other questions? Awesome. Yeah, thank you for that question. That one's definitely a difficult sticking point there. All right, so set methods. So we already saw add and remove previously. So the add method adds a specified element to a set. But keep in mind, if you try to add something that's already in the set, it's not going to have any effect. Your set's still going to be the same because you can't have multiple of the same element in a set. Then there's the remove method, which we saw on the previous slide. You can it removes a specified element from a set. Here in this example, we add 5 to the set. And then in this example here, we remove 3 from the set. You can see here that the set no longer contains 3, though it contained it up there. This set started out without 5, but now it contains 5 here for after we use the add method. We can also copy the set using the copy method, and it returns a copy of the set. So you might remember in our operators lecture, we were talking about the is operator. So the is operator is an identity operator, and it basically determines whether or not the things you're comparing are the same object, whether or not they reference the same exact object in memory. So in this particular case here, I create my set 1, 2, 3, 4, and then I set your set is equal to my set. So I assign my set to your set using the assignment operator. Then I check is your set is my set is basically the question I'm asking here with this Boolean expression, and that's true because they are the same exact element in memory. So now something that's important to note here is that I take my set and I add 5 to it because they are the same, because my set is your set. When I added 5 to my set, then I output your set, and notice that your set now contains 5. So this is something that's extremely important to recognize in Python, and it will trip you up at some point, I guarantee it. If they're referencing the same exact object in memory, then and this evaluates to true, the is, then when you modify one of those, it also modifies the other one. So keep that in mind. If you want your set to be different from my set, then you have to do your set equals my set dot copy. So this returns a copy of the set, but it's not the same set anymore. They aren't referencing the same set in Python's memory. So now when I check, is your set my set? When I do this Boolean expression of your set is my set, that returns false. They are no longer the same exact set, though they do contain the same values because I did my set.copy. So your set is a copy of my set, but they aren't the exact same reference in memory. So now if I remove 3 from my set, you can see that my set just contains 1, 2, 4, and 5, but your set still contains 1, 2, 3, 4, and 5. It didn't remove 3 from your set like it did add 5 to your set up here. So I know that can be a little tricky there. Any questions on that?
Yeah, so saying your set is my set is different from saying y is a function of x.
Correct. Yeah. Yeah. So like y is a function of x is that's more like, you know, defining a relationship between two variables. But in this particular case, we're actually the relationship between the two variables is that they are the same exact value in memory. So they're storing the same exact reference in that sense. So they're both storing the same exact set in memory. Does that help clarify things, or is there any follow-up questions to that?
Yeah, it's clear, it's clear.
Awesome. Yeah, thank you for the question. Again, like if you have any questions, please don't hesitate to ask. If you have the question, chances are somebody else has the question. So keep asking away. Any other questions on this? Awesome. So we have more set methods here. So if you're familiar with sets in math, maybe specifically discrete mathematics, there's a bunch of different operations that you typically do with sets. There's set difference, there's an intersection of sets, there's the union of sets, and there's a bunch more that you can find at W3 schools here, but I'm just going to talk about difference, intersection, and union here. So set difference is basic. When you call the difference method on a set, it returns the elements in one set that are not in the other. So the important thing to note here is that it returns the elements that are in the set that you call the method on that are not in the set that you pass as a parameter to the difference method. So 1, 2, 3, and 4 is the set that I'm calling the difference method on using dot notation. And the set that I want to compare it to, that I want to determine the set difference with, is 3, 4, 5, and 6. So this will return the elements that are in the set that I'm calling difference on that are not in the set that I'm passing as a parameter to the difference method. And anytime you pass something into the parentheses here of a method or a function, it's called a parameter, or an argument is another word you might hear there. So these sets both contain 3 and 4. But this set contains 1 and 2, while this set does not contain 1 and 2. Notice that this set here contains 5 and 6. This set doesn't contain 5 and 6, but what's output is 1 and 2, because it's basically subtracting, if you will, this set from this set. So we remove the elements that both sets share, and then just output the remaining elements of the set that you call the method on. So this just outputs 1 and 2 here. Then we have intersection. So the intersection of two sets is a set that contains the common elements. Hey.
Sorry for interrupting.
No problem.
In the difference.
Yeah. Did I lose you? Hello? I think I lost you. If maybe you're having some difficulties with your audio, just let me know when you fix that. And
this first set doesn't have a 6, or the other one has a 6.
Correct. Yeah. So this.
Hello?
So the set that. Can you hear me?
Yeah, I can hear you now.
Okay. Cool. Yeah. So this set here, the set that we're passing as a parameter, it does have a 6 in it, but since we're checking the set difference on this first set, and evaluating the difference between this set and this set, We only return the elements that are in the first set and not in the second set. One way you can think about it is you're basically subtracting. So imagine this is set A on your left. You're subtracting set B from set A. So it's like you're taking set A on your left and you have set B on your right. You're subtracting the two. So you do you subtract the common elements essentially between them, and you output just what's in the set that was on your left. You kind of ignore what was in your set on the right that wasn't in your set on the left.
Okay. Clear.
Just
Awesome.
a follow-up right there. Otherwise, what instruction would return 5 and 6 when you compare these two sets?
So if we wanted to return 5 and 6, that's a great question. Yeah, if we wanted to return 5 and 6, here, let me just let me just exit out of this and just show that real fast. Just gotta find PyCharm. All right. So if we instead wanted to return 5 and 6, what we would do here, I'm just going to restart this REPL environment. So we would have, if we instead want to return 5 and 6, we want to take, sorry, I just need to position these right so I can see what I was working with. All right, so we would take the set 3, 4, 5, and 6, and then we would call the difference method on that set and pass it the set that was initially on our right. So now we get 5 and 6. So what you want to do is whatever is on your left here, or whatever you're calling the difference method on, whichever way you want to think about it, both are perfectly valid. Whichever one you call the method on, that's what you want to look at, which elements are in that set that aren't in the other set. Any further questions on that?
Thank you.
Hello.
Hey.
Hello.
Hi.
Hi. Yes.
Go ahead.
Hello. Yeah. My question here is that can you, instead of this for all these three functions, let's say the difference, intersection, and the union, instead of calling off all the sets, like the first one, like for the difference 1, 2, 3, 4. I thought if, like, say you've name it, let's say you've named the first set A, then you've named the second set B. Instead of calling it with all its content, can you just write A then dot difference B?
Yeah, we could definitely do that. So say we wanted to assign A equals the set 1, 2, 3, 4, and B equals the set 4, 5, 3, 4, 5, and 6, then we could do A dot difference B, and that outputs the same thing that was in here. Yeah, great question. You can definitely assign them to variables first and then call dot difference on that. Awesome question.
Thanks.
Yeah, these are all great questions. I'm loving them. Keep them coming if anyone has any. Awesome. All right, so back to this. So for intersection, so set intersection, basically it returns the set that contains the common elements of 2 or more sets. So in this case, when we call the set intersection on 1, 2, 3, 4, call it using dot notation, and then we use our intersection method, again with the parentheses. Within the parentheses, we pass another set as our parameter. Now we just look at what are the common elements of these 2 sets, and that's going to be 3 and 4 because they both contain the values 3 and 4. In this particular case, it doesn't matter what's on the left and what's on the right? Because it's only what's in both sets. So if we put 3, 4, 5, and 6 on the left here, and then 1, 2, 3, and 4 on the right over here, then we're still going to get the same resulting set here because they share the same elements regardless of which one you're calling the intersection on. So this one, order matters, difference, order matters, with intersection and union, actually, order doesn't matter. So for union, it's kind of the opposite of intersection in a way. It returns a set containing all of the unique elements present in 1 or more sets. So in this particular case, we again have our first set 1, 2, 3, 4. We call the union method using dot notation. We have the parentheses on union to signify that it's a method rather than an attribute. And then we have the other set that we want to union the first set with. And then this returns a set that contains all of the unique values of both sets. So recall that sets can't have duplicate values. So even though we're unioning these together and they both contain 3 and 4, we don't see 2 3s and 2 4s in here because they all have to be unique values. So this just returns all of the unique values there. So it's like combining the two sets. So now we have 1, 2, 3, 4, 5, and 6. Again, this one order doesn't matter. We could have put 3, 4, 5, and 6 in the place of 1, 2, 3, 4, and basically just swapped these two sets. If we swap those two sets and then still call union on it, we're going to get the same exact output. It's only with difference that order matters, and there are some others from W3 schools where order does matter. I highly encourage you to play around with those, but we're just not going to focus on those today. I don't want to overwhelm you with too many methods and things here for sets. So any other questions on the set methods? They've been awesome so far. All right, great. Okay, so we're going to learn about a new operator here. It's called the in operator. So the in operator can help us determine if an element already exists in a set by using it to form a Boolean expression. So I created this set, my set, and I put David, Matthew, Eric, and Sean in this set. So if I want to see if David's in that set, I can check, is David in my set? This returns true. If I want to check if Josh is in my set, I can do Josh in my set, and that returns false because Josh is not in this set. So the in operator is super helpful for determining, so say you have a guest list. Say you have a guest list stored in my set. So say this is my guest list here, David, Matthew, Eric, and Sean. And I'm trying to determine, someone comes to the door and I want to determine, are they on the guest list? Do I let them in? So I check David in my set, true, David can come in. But then I check Josh in my set, Josh isn't in the set, so he's not on the guest list, so Josh can't come in. That's kind of the idea behind this here. You can check membership, which is extremely helpful in a lot of situations when you have a set of, say, like you're trying to validate certain things. So if you're getting input from a user and you want to validate that it's a legitimate value, you can have your set of legitimate values, and then you make sure that the value they passed is in your set of accepted values. If it is, then you're good to go. If it's not, maybe you raise an error and let the user know, hey, that value is not acceptable. We only accept these values. So lots of applications for the in operator. This doesn't just apply to sets. This applies to most data structures. So just keep that in mind. Any questions on the in operator? Cool. Something else to note here is that, I could have stored David in a variable. So say I put David in a variable and I called that variable me because my name's David. So, and then I do me equals David. And then I check me in my set, that returns true. And I could store Josh as friend. So I have a variable friend equals Josh, and then I could check friend in my set, and that would return false because Josh is not in my set. Something important to note here is that whenever you're referencing variables, you don't put the quotes around them. So see, I set this variable my set equal to this set here. Any variable shouldn't have the quotes around it. I know there was a few questions about that on the assignment. So yeah, you don't put quotes around your variable names, but if you're doing a raw string value, you do put quotes around it, and they can be single, double, triple, single, double quotes, or like a triple single or a triple double, like we talked about in our last session. All right, so I think I already asked, but just to be sure, any questions on the in operator? Awesome. All right, so some additional resources for you all. if you want to learn a little more about what we went over today. I included them at the end of the PowerPoint. So for conditionals, a link to W3 schools, there's an exercise at the bottom of it, but for learning about conditionals, it should review just about everything we went over today. There's just some things that might not be familiar to you on there. Don't worry about that. We'll get to that stuff down the line, because they might talk about other data structures and things there. For learning about sets, you can read more about them on W3 schools. And then there's set exercises here. I don't know if anyone used the exercises that I sent in the last PowerPoint, but I always like to include some exercises for you to get some practice with them. And I highly encourage all of you to practice with them as much as possible. You know, it never hurts, basically. All right, so that's it for this PowerPoint. For the slides for today, any questions on the material that we reviewed today before I move on to the next thing I wanted to discuss? All right, so let me just make sure. Okay, cool. So one thing I wanted to mention is that we now have an assistant coding teacher, and I wanted to introduce him to you all. His name is Gaurav. I hope I'm pronouncing that right. He is going to be helping out with the class. So on days where I'm not available for a lecture, Gaurav is going to take over, and he'll basically, what we're thinking is I'll record the lecture. I'll have you all watch the lecture when I'm before the lecture time, and then Gaurav will be in our actual lecture meeting, and he'll be available to answer any questions that you might have. And what I'm thinking is maybe in those cases, you guys can review the assignment and ask questions as needed. So please, everyone, give a warm welcome to Gaurav. He's helping us out a lot here. And if you want to introduce yourself, please go ahead.
Thank you so much, David. Hello, everyone. I am Gaurav Nayak. I am joining you guys from Canada, where I am pursuing my master's here at University of Windsor. Just a little bit of a background about myself. I have my residence in India, and I have 4+ years of experience in a multinational IT company where I have developed websites based on Java, Angular, Oracle PLSQL, and there were tons of tools that we used in order to develop the website and deliver it to our clients. I started my master's in the year 2019, where I had to pursue my research on deep learning, machine learning, artificial intelligence, and that's where I started learning Python and coding about it. So I have almost 1.5 years of experience now. And yeah, pretty much that's it. I am very, very glad to join you guys, and I'll try to help David as much as I can. Thank you, David, for having me here.
Thank you, Gaurav. I really appreciate you volunteering to help us out here. This is awesome. So anytime that you submit an assignment or you have any questions for me, please also CC Gaurav. I will start including him on our email chains from here on out. He'll be able to, if I'm unavailable and not able to get back to you, he'll be able to help out with questions as well. So thank you again, Gaurav. I really appreciate your help here. Looks like something in the chat. Awesome. Okay. So let's see. I wanted to go over the assignment very quickly for the week, and then I'm gonna and then I'll review basically what I had for the assignment for last week. Or maybe we'll go over some demo, and then I'll review what I had for the assignment last week. All right, so assignment 3 is an activity suggestion app. Basically, your client is extremely indecisive and with what they want to do with their free time, and wants you to develop a simple program to make suggestions as to what they could do based on a few factors. This program should be able to store the weekday indicator, whether or not it's a weekday, the current weather, and the funds the user has available to spend. So for weekday indicator, just want to be clear, this is supposed to be a Boolean value, either true or false. And then the current weather and the funds the user has available to spend. So the client lives in a place where the weather is always either nice, raining, or freezing. So the program should verify that the weather entered matches one of these values. So like I mentioned earlier, sets are a great way to do this. So my hint here is to use a set, and another hint, use the in operator for this. So after verifying that the weather value entered is valid, the program should do the following. In the case that it is a weekday, the program should output a reminder stating, you may have work or school today, but here are some suggestions. If not, then, and this is still in the case that it's a weekday, then in the case that the weather is nice, the program should output, the weather is nice, so let's do something outside. Then in the case that the user's available funds are at least 100, the program should output, let's go to an amusement park. Otherwise, the program should output, let's go for a walk in the park. And now this otherwise is down here from this then. So then the weather is nice. Otherwise, in the case the weather is raining, the program should output, it's raining outside, so let's do something indoors. Then in the case that the user's available funds are at least 50, the program should output, let's go to a museum. Otherwise, the program should output, let's stay in and watch movies. Now this otherwise again is for the weather aspect. So we have then in the case the weather is nice, in the case the weather is raining, otherwise the program should output, it is freezing outside. If you leave the house, make sure to bundle up. And then in the case that the user's available funds are at least 150, the program should output, let's hit the slopes and go skiing. Otherwise, the program should output, let's stay in and drink hot chocolate while watching movies. So now this otherwise comes to the case that it's not a weekday, so it's a weekend. So otherwise, the program should output, it's the weekend, woo, let's decide what to do. Then in the case the weather is nice, the program should output, the weather is nice, so let's do something outside. Let me just, it's bothering me that I didn't reformat this, so let me do that now. Cool. Then in the case the weather is nice, the program should output, the weather is nice, so let's do something outside. Then in the case that the user's available funds are at least 100, the program should output, let's go to a concert at an outdoor venue. Otherwise, the program should output, let's go on a hike somewhere. And then this otherwise is again for weather. So, we had the, in the case the weather is nice. So now, otherwise in the case the weather is raining, program should output, it's raining outside, so let's do something indoors. Then in the case that the user's available funds are at least 50, the program should output, let's go to a comedy show somewhere. Otherwise, the user's funds are not 50, the program should output, let's go on some free tours of the local places of worship. So now this otherwise, again, back to weather. So we had in the case that's nice, in the case it's raining. So otherwise, the program should output, it is freezing outside. If you leave the house, make sure to bundle up. Then in the case that the user's available funds are at least 150, the program should output, let's check out a local bar and or arcade and play games. Otherwise, the program should output, let's just call some friends and see if they want to come over and play board games. So I'll send out this assignment in an email following up after this class, and also share the document with all of you. Any questions on the assignment while you have me?
Hello.
Hi.
I have a question, but not on this assignment. Okay, the other assignment that was given, the truth is I didn't even know where to start. Like I didn't know how to handle it. So I didn't do the last assignment.
Okay.
So I don't know.
We're actually going to review that in a second here. Basically what was expected for that assignment. I'm going to do that at the very end though, just because I'm going to stop recording just so that like the answers aren't there for future iterations of this class. But we will go over that, and then maybe that'll resolve some of your questions. And if it doesn't, can you email me after class, and I'll help answer any questions you might have, provide any guidance. A number other students reached out with questions as well. Please don't be shy. Everybody had some struggles with the assignment. I think I might have made it a little too difficult for one of the first assignments, but so it's understandable that you're struggling a little. But yeah, does that sound good? We'll review what I was expecting for the assignment at the end, and then if you still have questions, email me.
Okay. Then.
Awesome.
No problem.
Awesome. Thank you, Solomon. Any other questions?
Well, I think mine will be similar to what I'm seeing on on this assignment in particular is that it's like we will have some sort of a data set where we keep the data which will say the balance is this much, the balance is this much, and then kind of instruct the program to check the balance and then return whatever answer we have. So I think if you handle if you guide us through the assignment 2, it will be the same solution that will happen here.
Right, exactly. Yeah. I'll guide you through kind of like what I expected and you know how I did it. Like there's a ton of different ways that you can approach the assignment that I gave. There's the way I did it isn't necessarily the right way to do it. There's a bunch of different ways you could do it. There's a number of things that I haven't taught you yet that you could do. I know in some people's assignment they did some things that are kind of jumping ahead a little bit, which is totally okay. If you want to do your own research and find out how to do it in a different way, that's totally fine. I'm just going to show you basically how I did it with what we've learned so far. But yeah, we will go over that, and please, if you do have any questions after we go over it, don't hesitate to reach out. Awesome. Okay, so I just kind of want to show you. So these are basically all the Boolean expressions that I had created, or the Booleans that I created, and I used throughout the PowerPoint here. So I just kind of want to show you what happens if we play around with these a little bit. So all of them are true. If everything's true, and I run this this demo thing here, then if everything's true, we output Boolean 1 is true. At least one of Boolean 1 and 2 is true. So that's coming out of here because we had an or, so we can't tell if it's both or one. And then Boolean 1 is true is here. So we didn't output Boolean 1 is false. So that comes from this if statement here. Then we have Boolean 1 is true. Who knows about Boolean 2 though? So that's coming from here because we just had this if here. We never evaluated this part here to determine whether or not Boolean 2 is true. So who knows? And then both Boolean 1 and 2 are true. So that's this if here, because both of them are true, because everything's true right now. So that outputs both Boolean 1 and Boolean 2 are true. We never evaluate these parts here, but there's no need to because we already know that they're both true. In this case, we print Boolean 1 is true again. So that's this one here. And that's, shorthand. Just don't really do the shorthand for now. I want you to, use your indentations, use multiple lines, things like that. And then we have this other shorthand here, the shorthand if else. That's outputting Boolean 1 is true here because Boolean 1 is true. Otherwise, it would output that. And then in this one here, Boolean 1, Boolean 2, and Boolean 3 were all true up at the top. So that outputs this line here. And who knows about Boolean 4? Yeah. So let's see, if I make Boolean 1 false and then run this again, we're going to get different outputs. So now it outputs that. So we don't get any output for this line here because there's no else block, so nothing outputs there. Here we still output at least one of the Boolean 1 and Boolean 2 is true because Boolean 2 is still true. Here we output Boolean 1 is false because this evaluated to false, so we came to our else block here. Here this evaluated to false, so we came to our else block here. So we output Boolean 2 is true. We also know that Boolean 1 is false. So we see that output down here. And then here this evaluates to false because we did an and. So this one's false, this one's true. So this evaluates to false, doesn't output this, but it does output it outputs this line here. Boolean 1 is false and Boolean 2 is true. We can see that line here. And then again, for the shorthand, Boolean 1, for the shorthand, because we don't have an else here, nothing outputs. For this one here, Boolean 1 is false outputs because we do have an else in this shorthand. So we see the Boolean 1 is false there. Then here, because Boolean 1 is false, we don't evaluate any of this in here. We come down to the else block here. We check Boolean 4 and it says Boolean 1 is false, Boolean 4 is true, and who knows about Boolean 2 and 3 because we just completely skipped them. So I could keep going on and on about this, but I hope you kind of get the picture there. If you would like, I highly recommend going through this because this will be part of the recording. Maybe go through this after, type this out yourself. It always helps a bunch to type out all of these values yourself, and then just get that muscle memory in there basically, and then you can play around with the values of Boolean 1, 2, 3, and 4 and see how that changes the outputs here.